So good to see you all. Before we start, if you have seen Groundhog Day movie, shout yes or raise your hand. Okay, great. So you resonate with what I'm going to talk about. Chapter 1. I want to take you through an imaginary journey. So please close your eyes and follow my word. Actually, don't close your eyes. Health and safety issues there. I don't want to be responsible for that. But imagine you're working for a successful e-commerce business. It's the last quarter of the year, and hitting your revenue target hinges on everything in this quarter going well, very smoothly. You're deep in your sleep, 6 o'clock in the morning, your alarm clock goes off, drags you out of your sweet dream. And while your brain is waking up, you start remembering that, oh, this is a big day for our business. It's Black Friday day, and everything has to go well without a problem for us to hit our targets. And indeed, it starts well, until it is not. So you start seeing some small chatter between engineers happening, something doesn't look quite right, and before you know, it blows up to a full-scale incident. And you see incident managers and engineers working frantically to fix the problem. Eventually, they manage to fix the problem, business is back on its feet. But you just observed an incident, major incident, unfolding before your eyes. What have you learned? Fast forward 24 hours. You're working for a successful e-commerce business. You're sleeping tight, 6 o'clock in the morning, alarm clock goes off, drags you out of your sweet dream. And while your brain is waking up, you remember it's an important day for your business. It's Black Friday. Everything has to go extremely well for you to hit your revenue target. And you get the story. It doesn't. And the same incident happens again. And you get to observe a different group of people, a different incident manager, group of engineers solving that incident. What have you learned? Now, imagine the same thing happens 18 more times. And if you are still in sane mind, what have you learned? So I leave that question with you for a few minutes to see what you come up with. But later on this talk, we will compare notes. Chapter 2. Learning how to respond to incidents is hard. It's really hard because incidents are complex. Our systems are very complex. They're socio-technical systems. You can't put a clear boundary between where the technology ends when the people part starts. And that's constantly moving. Add on top of that, it's very, very difficult, next to impossible, to experience the exact same incident more than once. It will be a different day, it will be a different time of the day, the market condition out there will be different. If all of that is same, the software is constantly changing thanks to continuous delivery. And even if you manage to have everything else the same, the fact that your company has seen that incident before, your mental model is different. So it's really hard to experience the same incident twice, unless we could jump in a time machine and experience it, which is not possible, unfortunately. So then how we can answer some very important questions about how we respond to incidents, like, what if we escalated sooner? What if we delegated better? What if instead we raised the severity to SEV 1 earlier? What if we stayed at SEV 2 severity? Would it make any difference? The point I'm trying to make here is each incident is unique. It's unique in that moment of time, the combination of people, technology, and other conditions. chapter 3. I know I just dashed your hope in terms of experiencing the same incident twice. And it's really hard, I don't take that as a statement. But there are ways that we can get close to it and make it possible to experience the same incident twice and learn from incidents. One of the techniques we learned is called staged work. And we set ourselves a mission to get as close as possible to replicate an incident so we can learn about incident response. If you, in your organization, if you are doing incident simulations or thinking to do incident simulations, please raise your hand. Okay, fair bit of hands going up. So there are multiple different ways and techniques to simulate incidents, from very basic ones like tabletop exercises, some techniques like choose your adventure or Dungeons and Dragons, and of course there is the stage work. So I'll tell you what a stage work is not before defining what it is. It's definitely not choose your adventure, because the path is very clear in choose your adventure. It's just one scenario that you can choose what scenario you want to happen, and that exactly happens. And it's not Dungeons and Dragons either. The stage words refers to controlled environment for simulating a real-world incidents or real-world events. And this environment is often used to study professionals' skill set in responding to anomalies. In our case, we designed stage words to study IT incident response and how professionals respond to incidents. There are a couple of key points to bring up here. First of all is stage words. They're open-ended. There is not one solution. It can take many different routes. And that's actually the feature of the technique. Then the second point is very important, what level of detail you replicate in your stage work to make it realistic. Obviously, it can't be the whole detail because it will be real world, but if you pick that wrong, then it won't feel realistic. So how our stage work look like? We picked 20 incident responders with various different level of experience, all of them been involved in fixing the incidents itself, so they were not stakeholders, but incident resolvers, and from different companies. And then it comes to deciding what level of details we want to replicate in our stage work. Very soon, we realized that engineers and techies are very particular about technical details. We couldn't mock the system. They would jump on command line, terminal, SSH, top, this and that, and if the bits and bytes doesn't match with what they see, it throws the credibility of the stage work out of the window. So we ended up building the whole tech stack that is available, and it was available on the internet, and when it was breaking for real. The second element was the tool, monitoring tools or observability tools that people are used to using. Again, the metrics they see on the tools should match with the state of tech in real life. Otherwise, they wouldn't believe it. So we learned that the hard way and put a lot of effort to create that. The third element was creating a social environment around incident. Incident response is a team sport. So it's not one person on its own. So we ended up creating an organizational structure around stage work for the person to experience what you would have experienced in real life, or she would have experienced in real life. Like demanding stakeholders, senior stakeholders, fellow engineers that some are less experienced and shy to speak up, and some are very confident and definitely know that they have the answer and expect everyone to follow them. And that added to reality. And the final aspect of it was the communication channel. Again, we realized it's very important to have a similar communication channel that people using real life. So we picked up a Slack and incident bridge on a Slack. Now we get into the fun part, the actual incident. Have you ever seen an incident like this? These plates are broken, but not broken at the same time. As soon as you open the window, they will be broken. But there are many factors in the properties of the plate. You know, if it was plastic, it probably wouldn't break. The door itself, the glass on the door, if it wasn't any glass, it would have fallen down and broken in the first place, or how high the cabinet is. All of these conditions are referred to as latent condition, and we see that pretty much in many real-life incidents. So this is our scenario. It starts with a group of people getting initial report that something might be wrong, might not be wrong. So the Bob customer services start getting those reports and share it with the rest of the team, and a couple of engineers casually looking into. And then things start to get more serious, more people are reporting, so everyone is all of a sudden interested. And while all of this going on, Shay, another engineer, on his desk enjoying a cup of tea after refreshing cache is something that he does every day. Why, and pretty normal operation, why would it cause problem this time around? Not knowing that a couple of hours before, some API secret key changes were deployed into an environment, and the refreshing the cache will trigger the whole thing. So he was enjoying his time, completely oblivious to what was going on. And then there was a change that went in a couple of hours before with those API secret key changes. And while all of these going on, which simulate a real-life incident, people participating in an experiment are expected to find a way to fix the incident, and they have 25 minutes for it. So, what we learn from this experiment? 13 out of 20 people, they managed to fix the incident within 25 minutes time range. Some earlier, it took less time. For some, it took longer time. We realized that the resolution time had no correlation with people's experience or the level of competency. With one incident anyway, it's very difficult to pinpoint that. But also, it reminded me of a quote from Dr. Richard Cook, which said, good results come from experience, experience come from bad results. So all the participants, they were good and were learning. Then we started the hard work. We had gigabytes of video recording of evidence, chat logs, and the actions that people did during an incident, and we were going through that. And we soon realized that we need some sort of a framework to be able to categorize this evidence and make sense of that, which we borrowed from work of John Oswald, he groups the incident-related activities to 4 groups of diagnostic, therapeutic, recruitment, and status and reporting activities, which I'll dive into them one by one. So, diagnostic activities. It's all about absorbing signals that are coming your way during an incident and making inferences. For instance, forming an idea that what could be happening here, or deciding on a severity. One thing that was pretty obvious was there are a huge number of signals that are coming towards the incident resolver. It's very difficult to make sense of all of them. It's virtually impossible to decide which signal is more important than the others. It's very easy to miss unimportant signals. To give you an example, some of these signals can come from your monitoring tools, like the metrics that you see, or from people in the chat. Oh, I remember something like this has happened before. Or some of them could be completely out of your organization. I interviewed someone after CrowdStrike incident. It was fascinating. He was talking about walking into the office in the morning, noticing a blue screen, and him and a group of engineers just desperately trying to find out what is going on. On the other corner of the office, it was a BBC TV up there with a crowd strike and impact of it on everyone. But who watches the news when you're trying to fix what is going on? So they were trying to work out what is going on, and the cause of the issue was just broadcasted behind them, and they were not aware of it. So that's also a signal. And sometimes signals happen even before the incidents, like the changes in our case. One interesting observation we had was around severity. While everyone was briefed, had the same briefing on how to decide about severity, people had different opinion. What is the severity of the incidents? And what was more interesting was that the severity of the incident didn't have any bearing on the resolution time. The SEV2s solved the incident quicker than SEV1s, which corroborate with the work that M-Groups shared in SREcon a few years ago. Now, there's a caveat there that you could say that, well, everyone knew this is an incident and they came in to solve the incident. You know, I take that. But the real point is, be it SEV1 or SEV2, didn't make any difference. What did make a difference, however, was people who spent a lot of time arguing on what severity should be. They ended up having less time fixing the actual incident. So I think that was an interesting takeaway from that. Next one, therapeutic activities. So these are all the interventions that incident resolvers are making in attempt to fix the incident. And I chose the word attempt because not all of those actions will fix the incident. In fact, we just take those actions based on various level of confidence. Sometimes, like, we don't know what to do, let's restart. Okay, that's an example of therapeutic action. Now, rollback is another example. Now, in this case, we noticed that most people decided to roll back changes to a service called payment service. Why not? They knew that there's a problem affecting only 2 currencies. A couple of hours ago, there were a change on a service that is called payment service related to currencies, so it makes sense to roll back. And they did roll back, but only to learn a few minutes later that it had no impact on the situation. So it didn't make things any better. Were they wrong? Did they waste the precious time of incident doing something that had no impact? It's hard to say. But what I can tell you for sure is people who took the decision to roll back that change immediately learned something that others who didn't roll back didn't know about. They learned that it was not about payment service and the rollback didn't work. And that's magical characteristic of therapeutic actions. The moment you take that intervention, it becomes a signal. It becomes a diagnostic, which you can use to further your incident. The third group of activities, we call it recruitment activities. So this is about identifying and bringing people with expertise and authority who can come in and help you with resolution of the incident. Now, while, again, another caveat, this incident simulation were designed deliberately in a way that needed teamwork, i.e. no one person on its own could solve the problem. You needed those information planted in different places and you needed different expertise to fix it. So you could argue that it was designed this way. But I would say probably most incidents in real life are like this. The perfect incident is as soon as you're alerted, you know exactly what is wrong, what change you need to make to fix it, and you have permission and privileges to do that fix. How many of the incidents are like that? Not many. So what we observed here, before that, I'll talk about the graphs here. So we have an internal tool which analyzes interactions between participants in the incident. So the bars that you see, each bar represents a conversation, and the thickness of the bar is duration of that conversation. So it was obvious that the 2 groups of people, we call them solo artists and band members. Solo artists, if you were present in Dario's talk yesterday, it's a little bit like a heroes. Okay, they took all the burden of the world on their own shoulder. I'm gonna fix it on my own, looking into logs, jumping from this system to that system, and just trying to work out what is going on. and they were very stressed and active. And then there were band members who very quickly started involving other talents within the team to share the workload with. One thing we didn't do, and I regret, is for future experiments we definitely will do, is to ask about people's stress level and how much they felt that they're in control after the incident. I suspect there's a correlation between sharing the load and playing the team and the level of stress and control that people feel. I picked this example really stood out for me. Like one of the participants very early on specifically asked for people, let's form a team to fix this, which was interesting. The last group of activities, status and reporting activities. I call this necessary evil. So these activities, they're entirely different to activities that you need to carry on to fix the incident, but you have to do them. When an incident going on, there's a small group of people within the ring trying to fix the incident and can make a big difference. And there are a larger group of people from the sides of the ring watching it. They're desperate for information, what is going on, for various different reasons. They have different intentions, but they all need information. And sharing information with them, while it is important, but it takes away from the time that you have fixing the incident. For me, it's an interesting paradox in incident response. The more time you spend sharing information on what is going inside the incident, the less time you have fixing the incident, actual incident. So what we observed was there were people deploying different practices to allow themselves to spend time on fixing the incident. There were clearly a group of people who chose to ignore requests and demand for information. They provided concise updates and avoided engaging in conversation, so they spent most of their time fixing the incident. And there were a group of people that they felt they have to engage, and we called them engaging in stakeholder appeasement. When CTO or CEO ask you for information, you don't want to say, no, I don't have that information. And then the other interesting point was, in cases, it was happening that there were genuinely no update to share. But when they were asked, they felt obliged that, oh, I need to make up an update and share, and that stressed participants. I particularly like this template. So one of the participants, I think he borrowed it from his workplace, used the template to communicate with outside stakeholders. There's so much packed in one small template. Let's go through it one at a time. So at the top, there is purpose of the notification. This is incident notification and refers to problem with Japan and Turkey. Then incident reference. If you want more updates, go and check your ITSM tool for that reference. Don't come and hassle me. Then there was current status of the incident. This is all I know at this moment in time. If you ask me one more time right now, I just have to make up an update for you, which will be probably nonsense. And it will distract me from fixing the actual incident. And finally, timing of the next update. So leave me alone. Let me, is a polite way of, get off my back, let me fix this incident, and I won't ask anything until my next update time. So we went through so much. Just a quick recap of what we observed. There's a huge cognitive load on everyone involved in the incident response, and we could see people using different techniques to share that load or reduce that load. Also, there was obvious that there are some patterns that didn't help. For instance, some people, more experienced people, they reverted back to the muscle memory, the protocol that over the years been ingrained in their mind. In the first minute, I'm going to just raise an incident, let everyone know, and then I'm going to check the changes and do that without even thinking about it. So that helped them a lot. Then another group, they shared the load with the rest of the people available on the bridge and got help. So they immediately doubled or tripled the thinking power horse available to fix the incident. And it was very clear, trying to appease the stakeholders took a valuable time from fixing the actual incident, and it was not useful. Also, spending a lot of time on arguing what the severity of the incident should be. It wasn't as useful either. So these findings, some of them were very interesting and surprising for us. I'm curious if any of the things, the observations that I shared here with you, if it was surprising for you at all. And if so, please raise your hand. Well, that's great. Wasn't any surprises in this room. But certainly some of them were quite surprising. And if this experiment inspired any thoughts in you, how has this experiment can take shape and move forward, or things that you observe in the workplace, I'd love to talk to you. So please, let's have a talk, chat after this talk. So there were a couple of limitations with this experiment that we did. The first one, everyone walking into the incident, they knew that there's an incident. They're expected to fix an incident. And that doesn't happen in real life. You don't wake up knowing that at 10:15 there will be an incident. So that definitely affected people. And then the other aspect was, apart from the real user taking part in this experiment, everyone else knew what was going on. So it wasn't a real teamwork. So in future experiments, we want to address these limitations. So these are the three different, the next set of experiments that we want to run. One is doing a team Groundhog Day. So with more than one person from outside world, outside of our Uptime labs involved in the incident response, to see how the teamwork plans out. Take time limit out. Just let it go as long as it takes to see what we will observe there. And finally, get people involved in the experiment who are not really resolvers, who are interested in an incident but from further away, like senior stakeholders and execs. At the end, I want to leave you with a short quote from Professor David Wood. It took me a few years to start grasp the meaning of it, and I'm not yet sure I fully understand it. But resilience is a verb. It's what you do, not what you have. All of us, we constantly learn from incidents, and because of that learning, we build layers and layers of defense in our technology, in our processes, like multiple data centers or load balancing. And these layers of defense, they help us to prevent many, many incidents. But when every one of these layers collapse one after the other, then you get an incident, which, by the way, happens quite frequently. And that's when you rely on your team's skills and ability to deal with surprises and uncertainty to save your business. And this is what resilience is about. So in yesterday's talk, we had a few good examples of things that you could do. For instance, in Saga of Site Reliability Engineering, I think it was a talk by Daria. She talks about the team culture. She talks about how to remove heroism within your team so everyone can help. That's one thing. Or on Courtney's amazing talk on irony of automation, understanding that automation changes how you work in a day-to-day, and training your staff to be able to work with automation effectively is another thing you could do. And I'll offer you one more, which I think many people already might be doing, is running incident simulations to practice with your team, to practice dealing with situations of uncertainty and incidents. That's another thing that you could do to be more resilient. On that note, thank you very much for your time, and I hope you found it useful.